Okay, let's turn next to problem set 3, and you can see I still kept open my Excel sheet from problem set 3, because if you look at problem set 3, it is actually very similar. So buckles we have on the y-axis, well, that will become our y, and knives we have on the x-axis, so that will become our x. And instead of mother of pearl, steel, and demand, we just have constraints called 1, 2, 3. So what we can do is we actually can just copy that sheet and then work with that one. And we don't have to start from scratch. So I'll just right click and say create a copy, and then maybe I rename it into problem set 3. Okay, and again, where it says buckles, that is now y. And where it says knives, well, that's x. So y, x. Okay, so let's change it in the graph. Y and x. And so now we just have to change the parameters. So x has a 3, and then let's also, it doesn't matter. So x has a 3. The unit profit of y is 6. Yeah, and let's reset everything to 0 and 0. And the constraints, they are now not called mother of pearl, steel, and demand, but they are 1, 2, and with 2 you got to be careful because that has now greater than or equal. So they are not all less than or equal. So that will change the area of feasible production. So 2, we got to be careful for the sign. And we have the demand. Okay, so the first constraint 1, y is 2, x is 3. So y is 2, x is 3. Then constraint 2, 1 and 1. And for 3, yeah, x is 1 and y is 0, and we have 4, 5, but we have to be careful and change the constraint, the sign, and yeah, for 1 we have 18. And now you can see that our yellow area is actually not correct anymore, because the x plus y greater than or equal to 5, that would suggest that we have to go beyond. It's a little bit difficult to illustrate it in Excel, because what I could do is, yeah, I could change, for example, the area of feasible production, not to min, but to max. Okay, and then I copy down this one. But now you see it also highlights everything below the blue line, which it shouldn't do. Normally what you would do in practice, but I will not do that now because I don't want to let the perfect be the enemy of the good. We have to create another line underneath the constraint 1. And again, I can actually change them here too. So that is 1, 2, 3. And now it's picked up in the graph. So I would create for the constraint 2 a duplicate, and then I would just make a blank area underneath it. But yeah, we know that the lower yellow part shouldn't be there. Only the area between the blue and the orange line. Okay, So now, if we solve it manually, we would now add the ISO profit line, and of course Excel should generate that for us right now. But just to review again, so what is the ISO profit line? Because I have y on the y-axis, I would have to solve the maximization condition to 6y equals z minus 3x, and then I divide both sides by 6, and I get total profit c over 6 minus 3 over 6 times x. And the important part is, of course, now that the slope is the unit profit of x to the unit profit of y, and so we have an ISO profit line with a slope of -1/2. So let me just insert one. I go to illustrations, shapes, and I'll just take an arbitrary line that has a slope of -1/2, maybe from 6 to 12. And then I take this one and I try to shift it as far out as I can. And now we see, okay, the optimum solution should be 9 and 0. Okay, so let's see what we get if we use solver. Okay, so E3 by changing cells C3, D3, that's correct. And I need to delete the constraints, because for the second we need to take into account x plus y is greater than, equal or greater than 5. So we add them manually and we say, okay, the constraint 1, okay, total usage is less than or equal to the 18. Now we add the next one. Okay, 18. Okay, so now we add the next one. 2, total usage 0. So that needs to be changed to greater or equal to the 5. But then the final one is total usage for the demand is less than or equal to the 4. And that's it. So now we have E7, G6. Okay, well, it looks correct. And so we use simplex and we solve, and now we should see here 9 and 0. Okay, so now we got an error message and that doesn't look right. So I probably clicked something wrong in the constraint. So E3, so let me just delete again the constraints. Okay, so the first constraint is that the total usage has to be less than or equal to 18. Then we add, where it currently says 5, there needs to be greater or equal to the 5. We add the final one, which is total usage is less than or equal to the 4. So we click and look into the corresponding cell. Okay, E6 less than, greater, okay. So now let's solve it. Oh, that looks correct. I must have clicked something. So keep solver solution, okay. And we see we have now basically a corner solution. We only produce 9y and no x. And if we wanted to, we will now see in the limits report, I mean in the sensitivity report, if I just pull that up, So now we have a sensitivity report 2. You see we don't produce any X, and the reduced cost would tell us if we could increase the unit profit by 6 by reducing the cost of 6, then we will have a new solution. So let's see if we change that. So if, let's say, the price of X went up to 10, that's more than 6, and we run it again, solver, solve, okay, and now you see we would produce the optimum quantities would be 3 and 4. But yeah, let's just go back to where it was, 6 and 3. And let's take a look again at the optimum solution. And yeah, we could look now at the sensitivity report, the limits report, but I think that's clear. And what happens, however, the next thing is, so holding everything else constant, what would be the optimum solution if we change the prices? So the price of Y is 3 and the price of X is 6. And now you can already see how that rotates the isoprofit line, and if you shift it to the right, the optimum solution is probably now 4X and 3Y. So let's check this one. So everything should be the same. Okay, and we see indeed 4X and 3Y. Okay. Yeah. And yeah, we can see what would happen if we had, for example, greater demand like 5. So, or even 6. Okay. So what would you think is the optimum solution now? I would think, from looking at it, and it should be probably 6X and 0Y. So let's double check what we get. Solver, solve. Okay, and this is what we get. And relaxing the demand constraint even more wouldn't help, because in this case the constraint 1 would bite. So by playing around with some numbers, I hope you get a little bit of a feeling for things like shadow price and opportunity cost and those kind of things. Shadow price is opportunity cost. Okay, so that concludes problem set 3. And yeah, let's just stop here and then let's continue with problem set 4.